everyone! Here we are in our physics class. Now we are going to explain you how to solve problems with a double conversion factor. Okay, ready? Let's get started. Some people call this process as dimensional analysis. And other ones call this process like as the factor method of units conversion. But now we are going to change those names and call them the easy and nice conversion. Okay, let's continue. As an example of how to use the conversion factor to solve problems, we will use the following example. Number 1, an experiment was done to see the health effect of big amounts of aspirin on rats. Each rat gets 0.002 kilograms per day of aspirin. How many grams per hour gets each rat? Remember that the first step is to write the data in form of a conversion factor. Very well, we need to convert kilograms into grams and also days into hours. We need to write the conversion factor like this, 0.002 kilograms per day. Remember that here we need to write the number 1 because we want a fraction form. After that, in order to do easily this conversion, we have to draw a place the conversion factor of the first unit, in this case, kilogram. Now we are going to draw 2 lines like this. And remember that here we need to write the unit that want to convert. We need to convert kilograms into grams. Okay. Now we look for the relationship between grams and kilograms in a table of conversion. And remember that 1 kilogram equals 1,000 grams because the prefix kilo means 1,000 units. And this statement is equals to this statement because 1 kilogram equals 1,000 grams and 1,000 grams equals 1 kilogram. Okay, now we are going to write this statement as conversion factor. We have 2 conversion factors from this statement. The first one is 1 kilogram over 1,000 grams or 1,000 grams over 1 kilogram. Remember that this expression means the same thing. And now we are going to choose the best conversion factor for this place. Remember that this is the best conversion factor because here we have the grams in the top of the conversion factor. Now we are going to copy these values here. 1,000 grams over 1 kilogram. Okay? Now we are going to write the second space for the second unit, in this case, days. Another space for the second unit. Now day is now we want to convert days into hours. Now days into hours here. Here we have this statement. We have for this statement 2 conversion factors. 1 day equals 24 hours and 24 hours equals 1 day. All of these expressions represent the same thing and they are equivalences. Now we are going to choose the best factor to get the conversion. Here we have the hours in the bottom of the factor. Then we need to use this conversion factor. Okay, now we are going to copy the data in this part and the other data in this part. 1 day equals 24 hours. Okay, now we're going to do the next step. Okay, here we have the 2 conversion units, kilograms into grams and days into hour. Okay, now let's do the multiplications. Okay, we are going to use the hour calculator and the first one is 0.002 times 1,000 times 1 equals 2. Okay, 2 over 1 times 24, 24. Now we are going to cancel the units. Here, kilograms with kilograms. And here, days with days. Finally, we have grams here in the top of the fraction and in the bottom, hours. Okay, now we are going to do the division. 2 over 24 equals 0.083 grams per hour. And this is the result of this conversion. In other words, 0.002 kilograms per day equals 0.083 grams per hour. Okay? Let's continue. Okay, this is the example number 2. In a crime scene, a tire left in the mud each minute an impression of 8.7 inches wide. How many meters per second these tracks represent? Okay, remember that the first step is write the data as fraction because the conversion factor is a fraction. Okay, 8.7 inch over 1 minute. Remember that we need to convert inches to meters and minutes into seconds. Now, the next step is to make the lines for the first conversion factor for this unit. Okay, we need to look for this equivalence between inches and meters. But here, only have the equivalence between inches and centimeters. Don't worry, we write centimeters here before meters. Now, centimeters is here, okay? For this equivalence, we have this statement. 1 inch equals 2.54 centimeters, and we have here two different types of conversion factors. 2.54 centimeters equals 1 inch, or 1 inch equals 254 centimeters. All of these are equivalents. Because of this, all these expressions represent the same thing. Now we need to choose the best conversion factor. This is the best because here we have centimeters in the top of the factor. Now we are going to copy the values here and here. 2.54 centimeters equals 1 inch. Okay. But now we don't have meters. Remember how many centimeters are there in 1 meter? Yes, 100 centimeters are in 1 meter. Or in other words, 1 meter has 100 centimeters. Then we are going to write here another space for the next conversion factor. In this case, we are going to write here meters. And what is the best conversion factor for this space? 1 meter equals 100 centimeters. Okay, now 1 meter equals 100 centimeters. Very well. But this is only for the first unit. We need to convert the second unit. Now we are going to write another space for another conversion factor. Okay, in this case, we need to convert minutes into seconds. Seconds is here. Now, do you remember how many seconds are there in 1 minute? Okay, yes, 1 minute has 60 seconds, or in other words, 60 seconds are in 1 minute. Okay, what is the best conversion factor for this place? This is the best. 1 minute equals 60 seconds. 1 minute equals 60 seconds. Okay, now we are going to do the multiplications and we need to use our calculator. Okay, 80.7 times 2.54 times 1 equals 22.09 over, the other multiplication is 1 times 1 times 100 times 60. The result is 6,000. Now we are going to cancel the units. Inch with inch. Centimeters with centimeters. Minutes with minutes. and we have only meters here in the top and in the bottom of the fraction, seconds. Okay, now we are going to divide 22.09 over 6,000 equals 3.68 times 10 to the minus 3 power. And the units are meters over second. Okay? In other words, 8.7 inch per minute equals 3.68 times 10 minus 3 meters per second. Okay? Remember that you need to write these squares around of the results. Now, here is the last example. A car is traveling at 105 kilometers per hour. What is this velocity in miles per hour? Remember that you need to write the data as fraction 105 kilometers per hour. 1 hour. Now we are going to write the place for the first conversion factor. Remember that we need to start with the first unit, kilometers to miles. Then we are going to write here miles. And the equivalence between miles and kilometers is this. 1 mile equals 1.609 kilometers. And we can obtain of this statement two conversion factors. 1 mile equals 1.609 kilometers, or 1.609 kilometers equals 1 mile. We need to choose the best conversion factor, is this one, and we are going to copy the conversion factor here. Now, here 1 mile, and here 1.609 kilometers. Now, this is that for the first unit, it's correct. Kilometers into miles. Now we are going to convert hours into hours, but we have hours here. Then we are going to finish with the second unit. We are going to write here equals. Now let's do the multiplications. 105 times 1, 105. Over 1 times 1.609 is 1.609. Now we are going to cancel the units, kilometers with kilometers. And we have in the top of the fraction miles and in the bottom of the fraction hours. Okay? Now we are going to do the division. 105 over 1.609 equals 65.25, and the units are miles per hour. And this is the result. In other words, 105 kilometers per hour are equal to 65.25 meters per hour. Okay? Ready. And that's it. Easy peasy, nice and easy. See you. Bye-bye.